What if the moon crashed into Earth? I mean, picture this. It begins just as a light in the sky, but it's bigger than usual, brighter than usual.
First, people just stop and stare. They're snapping photographs, calling their families outside to look up at this bizarre phenomenon. But then, within a matter of days, that light fills literally half the
And
sky.
then within weeks, the ground beneath your very feet begins to tremble. But it's not from an earthquake, it's from the moon. And it is coming right for us.
Part 1. The scenario. Orbital failure. So the moon has orbited Earth for 4.5 billion years in absolute perfect balance. But what if that orbit just failed? What if it began actually falling toward Earth? We're not talking drifting here, not slowly wandering, falling. And the terrifying thing is, once it begins, absolutely nothing in the universe can stop it. Now, to really grasp the threat here, we need to understand the scale. The moon's diameter stretches a massive 3,474 kilometers. And its mass? A staggering 73 quintillion kilograms. That's 73 followed by 18 zeros. It's literally 1/4 the size of Earth itself. That actually makes it one of the largest moons relative to its host planet in our entire solar system. Right now, it's orbiting us at an average distance of about 384,000 kilometers. But that distance isn't just some coincidence. It's a delicate balance, right? A gravitational agreement between the Earth and the moon that's been maintained perfectly for billions of years. Break that agreement, and, well, you don't just get a disaster, you get a mass extinction. Part 2. What science tells us the physics of approach. Okay, so weeks before the moon even physically arrives, its intensifying gravitational pull would start turning our everyday tides into massive, rising walls of water. Entire coastal cities like New York and Tokyo, they'd be swallowed up completely. Then, mere days before the impact, that intense gravity would start warping Earth's very crust. Every major fault line would rupture simultaneously, triggering non-stop earthquakes, while volcanoes would completely darken the sky with ash. Then, at about 9,500 kilometers out, the moon crosses what we call the Roche limit. At this incredibly close distance, Earth's own gravity would essentially start tearing the moon apart from the inside out. The lunar surface would crack open. Massive chunks of rock, some literally the size of mountains, would just begin breaking free. The moon, which has been this single, silent sphere for 4.5 billion years, would just disintegrate. A ring of debris would form around the Earth. But we're not talking about the beautiful, distant rings of Saturn here. No, this would be a violently churning field of lunar rock. Some of these pieces would be hundreds of kilometers wide, and all of it would be pulled inevitably down toward Earth's surface. So the bombardment would actually begin before the main body even got here. These pieces of the moon, some of them larger than entire countries, would start striking the Earth. And each one of those impacts would release energy that completely dwarfs every nuclear weapon ever built combined. The sky would light up, but not with a sunrise, with fire. Now, if any fragment of the moon's dense core managed to survive that disintegration and struck Earth as a single mass, well, the numbers become almost impossible to even comprehend. The energy released in that kind of impact would be measured in the billions of megatons. To put that into perspective, the Chicxulub asteroid that wiped out the dinosaurs 66 million years ago, that released about 100 million megatons of energy. A direct moon impact would be thousands of times more powerful than that. The impact site, wherever it happened to strike, would just simply cease to exist, not even as a crater, but as a literal wound in the planet itself. Molten rock would be violently ejected into orbit, only to rain back down across the entire surface of the Earth. The global atmosphere would superheat, surface temperatures would skyrocket to levels that would instantly ignite forests, boil away surface water, and make the open air itself completely unsurvivable. Honestly, within just hours of the impact, the surface of Earth would look a lot more like the surface of the sun than the blue planet we know and love. So, what would actually survive? Nothing on the surface. No humans, no animals, no forests, no cities, no monuments, no record of absolutely anything we have ever built, discovered, or loved. The deep ocean might briefly shelter some microbial life, and organisms buried miles underground might somehow survive that initial firestorm. But the atmosphere, being completely stripped and superheated, would take thousands of years to recover, and that's if it ever recovered at all. Now, Earth itself would survive as a planet. It'd be scarred, radically reshaped, and probably tilted on a brand new axis. But it would keep orbiting the sun exactly as it always has. Just without us,
without anything.
Part 3. The bigger picture. Cosmic stability. Every single day, the moon rises and sets without incident. We completely take that perfect gravitational balance for granted. But space operates on timescales that are just too vast for us to really grasp. We exist right now in a precious window of cosmic stability. But remember, that window has been shattered before. The dinosaurs had zero warning when their time came, but we have knowledge. The real question is whether we'll use it wisely enough.
So do me a favor and look up tonight. Find the moon in the sky. Think about the fact that it is 384,000 kilometers away. And tonight, that is exactly where it belongs.